Usually when we talk about a nutritional deficiency, there is like a clear warning light on the dashboard.
Right, yeah. Like if you don't get enough vitamin C, you get scurvy.
Exactly. Your gums bleed. It's visible. It's immediate. And, you know exactly what to fix.
We generally like when biology gives us a clear, undeniable signal that something is going wrong.
But then you look at the human brain and the liver, and you realize that some of our most critical biological engines do not have a warning light at all.
No, they don't. Without the right fuel, they just slowly, quietly start running on fumes.
And according to the dietary data we're looking at in today's deep dive, over 80% of us are doing exactly that. We're running on fumes, completely deficient in a nutrient called choline, over 80%.
Which is wild because the Institute of Medicine officially recognized it as an essential nutrient back in 1998.
Right, 1998. And almost none of us are getting enough. So, okay, let's unpack this. How do we even begin to tackle something this systemic for you?
Well, we start by setting a very strict standard for the evidence. To cut through the noise for you today, we are establishing some ground rules for the sources we pull from.
Because there's just so much noise out there.
There really is.
Yeah.
So we're exclusively prioritizing trustworthy, high-grade human trials and rigorously vetted clinical data.
Love that.
Yeah, we are ignoring flimsy observational trends entirely and focusing purely on what has been proven to happen inside the human body in controlled environments.
Which is exactly what we need when the claims are this big. So, since our mission is to focus on robust, proven benefits, let's start where choline does its most famous work, the human brain.
Right, the brain.
We know choline is the direct precursor to acetylcholine. That's, the major neurotransmitter responsible for memory formation, focus, and even basic motor control.
Yeah, it's foundational.
But reading through the human randomized controlled trials, the RCTs we pulled, the actual cognitive improvements are staggering.
They really are.
There is a specific 12-week trial where researchers gave healthy older adults, ages 50 to 85, 500 milligrams a day of a specific form called acetylcholine.
And the outcomes of that trial were highly significant.
Yeah.
Compared to a placebo group, the individuals taking acetylcholine showed measurable improvements in both episodic memory.
And episodic memory is like your ability to remember specific events, right?
Exactly, like where you parked your car or a conversation you had yesterday. And it also improved composite memory, which is your overall global cognitive performance.
Wow. And it doesn't stop with healthy aging, which is what really caught my attention. The data on active cognitive decline is even more intense.
Yes.
In patients dealing with dementia, there are trials where they used 1,200 milligrams a day of another form of choline called Alpha-GPC.
Usually split into 400 milligram doses.
Right, 3 doses. And they saw significant improvements in MMSE and EDAS-Cog scores. For anyone listening who hasn't encountered those terms, what exactly are those tests measuring?
They are the gold standard clinical assessments for cognitive impairment. MMSE stands for the Mini Mental State Examination, which tests basic orientation, attention, and memory recall.
Okay.
And ADAS-Cog is the Alzheimer's Disease Assessment Scale Cognitive Subscale.
That's a mouthful.
It is, yeah. But it's a much more comprehensive test evaluating language, memory, and praxis.
Praxis being the ability to perform coordinated movement.
Exactly. When Alpha-GPC was added to standard therapy, these patients didn't just stabilize. Their scores actively improved.
That's incredible.
We are talking about meaningful upgrades in their daily function and behavior.
So thinking about this functionally, I like to picture the brain as this massive cellular internet.
Okay, I like that.
You have the raw fiber optic cables, which are the physical structures of the brain cells, and you have the electrical sparks, the signals jumping between them. If choline is literally building that infrastructure and fueling those sparks, are we essentially experiencing a lag when we don't get enough?
That is a highly accurate way to visualize the deficiency. And to understand how specific forms like acetylcholine and alpha-GPC fix that lag, we have to look at their unique delivery mechanisms.
Right, because not all forms are equal.
Exactly. Both of these molecules are designed to efficiently cross the blood-brain barrier, which is essentially the brain's strict security checkpoint.
Okay.
Once they get inside, they do dual duty. First, they provide the direct raw material needed to synthesize more acetylcholine.
So that boosts the signal strength, the sparks in the analogy.
Yes, the sparks.
Okay, wait, so it makes the signal stronger, but that doesn't fix a broken cell membrane, does it? I mean, you're just sending a stronger spark down a frayed wire.
That would be true if that was all it did. But acetylcholine has a second trick up its sleeve. It also provides the phospholipids required for neuronal membrane repair.
Oh, wow.
Yeah, it literally patches up the frayed fiber optic cables. Acetylcholine, for example, breaks down into choline and cytidine in the body. And the cytidine is ultimately converted into uridine, which provides the necessary nucleotides, specifically for patching up the structural membrane of the neuron.
So it's a comprehensive, simultaneous upgrade to the brain's hardware and its software.
Exactly.
That dual action makes so much more sense. You're fixing the wire and boosting the signal, so we know it patches up the wear and tear of an older brain.
Right.
But reading through these sources, I kept wondering, like, if it's this vital for maintenance, what happens when there is no brain yet? What happens at month 0?
Fetal development. This is arguably where the clinical data is the most profound.
Yeah.
Specifically during the 3rd trimester of pregnancy, which is a critical window for rapid brain growth.
There is a landmark randomized controlled trial from Cornell University in our stack that really highlights the stakes here.
Oh, the Cornell study, yeah.
They took pregnant women and gave them either 480 milligrams of choline a day or 930 milligrams a day.
And that higher dose is actually double the standard adequate intake recommended by health guidelines.
Double. And importantly, they didn't just look at the immediate health of the infants at birth. They followed these children for years to see how that prenatal environment played out over time.
Yeah, they looked at the 7-year follow-up data.
Right. At 7 years old, the children of the mothers in the 930 milligram group showed vastly superior sustained attention and faster information processing compared to the lower dose group.
It's amazing.
They were literally maintaining correct signal detection on complex tasks significantly better than their peers.
Plus, looking at another massive meta-analysis we have here, low maternal choline intake is linked to a 1.36 odds ratio increase for neural tube defects.
Wait, to translate that, it means the risk goes up by 36% if the mother isn't getting enough.
Exactly, 36%, which firmly puts choline in a very similar category of importance as folate during early development.
Yeah, I feel like everyone talks about folate.
The medical community heavily emphasizes folate to prevent neural tube defects, but choline is working right alongside it.
So I have to push back a bit on the standard medical advice here. What does this all mean for the standard prenatal vitamin?
Wow.
Because if 930 milligrams is driving these incredible, durable, 7-year cognitive benefits, are standard prenatals dropping the ball by not emphasizing this nutrient more heavily?
They often are, honestly, largely due to physical logistics. Yeah, choline is a very bulky molecule. To put an optimal dose into a prenatal vitamin would make the pill the size of a golf ball.
Oh, yikes. Nobody's swallowing that.
Right. So manufacturers often leave it out entirely or include a tiny negligible amount.
Yeah.
But to answer your question about whether we are dropping the ball, what's fascinating here is the underlying mechanism behind those 7-year cognitive benefits.
Okay.
It's all about epigenetics, specifically DNA methylation.
Okay, DNA methylation. We hear epigenetics thrown around a lot as a buzzword. We're talking about actually changing how genes are expressed without changing the underlying DNA code, right?
Exactly. Think of DNA methylation like volume knobs on your genes.
Volume knobs.
Yeah. You have your fixed genetic code, but methyl groups are physical chemical tags that attach to the DNA and turn the volume up or down on certain traits.
Oh, I see.
Maternal choline intake acts as a primary methyl donor. By providing a massive supply of these methyl groups during the 3rd trimester, the mother's diet is literally programming the offspring's neural growth.
Wow.
It turns up the volume on the development of the hippocampus, which is the brain's memory center.
That is incredible. We are physically twisting the volume knobs on a child's attention span 7 years before they ever sit down to take a math test.
And that is why the current adequate intake guidelines may be severely underestimating what is actually optimal for building a highly functioning human brain from scratch.
Now, developing a brain from nothing requires massive amounts of energy and massive amounts of lipids.
Absolutely.
And that logically leads us into choline's second major, yet somehow lesser-known physiological role. It acts as the primary manager of the body's fat processing factory, the liver.
The connection between choline and the liver is actually the foundational reason choline was classified as an essential nutrient to begin with.
Really?
Yes, it is an absolute requirement for hepatic function.
The history here is wild. I was reading about these foundational human depletion studies led by a researcher named Zeisel.
Oh, those are classic.
They took a perfectly healthy people, placed them in a tightly controlled clinical ward and fed them a diet that was completely stripped of choline.
Just completely removed it.
And within weeks, 77% of them developed hepatic steatosis, which is fatty liver disease. Just from removing this one single nutrient, their livers began to fail.
It's terrifying how fast it happens.
But the moment they reintroduced choline into their diets, the fatty liver rapidly reversed.
It is a direct causal relationship proven in human feeding trials.
Yep.
Remove the nutrient, the organ suffocates in its own fat. You restore the nutrient, the organ clears the fat.
And we bring this right into the modern day with a very recent 2025 RCT focusing on patients who already have AFLD, non-alcoholic fatty liver disease.
Right.
They gave these patients 2,400 milligrams a day of a form called phosphatidylcholine for 12 weeks.
And the results were fantastic.
Yeah, they saw significant reductions in liver fat, which they measured using CAP scores. What exactly is a CAP score?
The COPE stands for Controlled Attenuation Parameter. Think of it as a specialized ultrasound that is specifically tuned to measure the exact thickness and density of fat accumulating inside the liver tissue.
Oh, okay.
It gives us a highly accurate, non-invasive look at the fatty liver status.
Got it. So the ultrasound showed the fat was physically shrinking, and alongside that, they saw significant drops in liver enzymes, specifically ALT and AST, as well as a major reduction in oxidative stress.
Right, so ALT and AST are enzymes that live inside your liver cells. When your liver is inflamed or the cells are literally bursting open from too much fat, those enzymes leak out into your bloodstream.
It sounds bad.
It's very bad. So a drop in ALT and AST means the liver cells have stopped dying and leaking. The phosphatidylcholine completely restored the liver's functional capacity.
So to make this memorable, I was trying to visualize what's actually happening on a cellular level in the liver.
Let's hear it.
It seems like choline is basically the cardboard boxes and the packing tape that the liver needs to ship fat out into the body for energy. Without that packing tape, the liver can't ship anything, and the fat just piles up on the warehouse floor until the whole factory shuts down.
That is a perfect biochemical translation. If we look at the specific mechanisms, choline is strictly required by the body to synthesize phosphatidylcholine.
Okay.
And phosphatidylcholine is the necessary molecular wrapper for VLDL.
Which stands for very low-density lipoproteins, the shipping trucks in my analogy.
Exactly. VLDLs are the specific physiological trucks that export triglycerides, or fat, out of the liver and into the bloodstream so your muscles and tissues can use it for energy. If you don't have enough dietary choline, you cannot make the phosphatidylcholine wrapper, which means you can't assemble the VLDL trucks.
So the fat is just stuck.
The triglycerides have absolutely nowhere to go, so they accumulate inside the liver cells, causing steatosis, inflammation, and eventually cell death. It's a massive logistical bottleneck.
Okay, so if I'm listening to this at the gym or on my commute right now, I'm probably thinking, wow, choline is this magical cellular packing tape for my liver, and it's incredible fuel for my brain.
Right, you'd want to stock up.
Yeah, I'm going to go online, buy a giant tub of the absolute cheapest choline supplement I can find, and scoop it into my morning smoothie.
Oh, no.
But we need to pivot sharply here because the science says doing exactly that could be a massive mistake.
A potentially dangerous mistake, yes. This is where the nuance of nutritional science and understanding how our bodies process different forms of a nutrient becomes absolutely critical.
We have to talk about the cardiovascular risk associated with high choline intake.
It's a big deal.
There is a massive meta-analysis in our stack covering nearly 480,000 people. It found that every 100 milligram per day increase in dietary choline was linked to an 11% higher cardiovascular mortality risk.
Yeah, it is a highly significant association. An 11% increase in mortality risk for a mere 100 milligram bump is a signal we cannot ignore.
And the mechanism they point to is fascinating because it's not the choline itself doing the damage. It's our gut bacteria.
Yes.
Certain bacteria in our microbiome take free choline and convert it into a molecule called TMA. Then your liver takes that TMA and turns it into TMA.
Right.
And TMAO is a pro-atherogenic molecule, meaning it acts almost like liquid sandpaper in your arteries, actively promoting plaque buildup and cardiovascular disease.
But this creates what looks like a glaring paradox in the medical literature.
Yeah.
We just spent the first half of this deep dive explaining why you desperately need choline to survive, and now we were looking at data showing it might accelerate heart disease.
Exactly. If it's essential, but it also causes heart disease, what are we supposed to do? But the sources resolve this paradox beautifully with a crucial clinical trial that compared taking supplements to eating real food.
This is key.
They found that cheap, water-soluble salts, specifically choline bitartrate, which is the form you find in a ton of cheap bulk supplements, rapidly spiked those dangerous TMAO levels in the blood.
Right.
However, when people got the exact same amount of choline by eating eggs, where the choline is naturally packaged as phosphatidylcholine, their fasting TMAO levels did not rise.
The food matrix entirely changed the metabolic outcome.
Here's where it gets really interesting. If cheap supplements raise this heart risk marker, but whole foods don't, does this mean the delivery system is just as important as the nutrient itself?
I can confirm that is exactly what this means.
Yeah.
This isn't a contradiction in the science. It is a vital revelation about bioavailability and metabolism.
Okay.
When you consume cheap choline bitartrate salts, a large portion of it sits unabsorbed in the gut.
Oh, I see.
The bacteria there feast on it, ferment it, and generate that dangerous TMA. But when you consume phosphatidylcholine from whole foods like eggs, it is absorbed completely differently.
Because it's a lipid.
Yes, often as intact phospholipids, which means it gets absorbed into the bloodstream early, bypassing that massive bacterial conversion entirely.
So the body safely absorbs it before the gut bugs even get a chance to turn it into a toxin.
Precisely. This means that individuals must be incredibly strategic about the form of choline they ingest. We have to explicitly warn against using high doses of cheap bitartrate or chloride salts, especially for anyone with existing cardiovascular risks.
You're just feeding the TMAO pathway.
You are.
Knowing that the form dictates whether choline helps your brain or potentially harms your heart completely changes the game. So let's shift to how you, listening right now, can safely apply this knowledge to your daily life.
Let's do it.
Let's look at the baseline numbers. The daily adequate intake established by the IOM is 550 milligrams for men and 425 milligrams for women.
And as we discussed with the epigenetics data, during pregnancy, that demand goes up significantly, likely closer to that 900 milligram mark if you want optimal cognitive development.
So ranking the top natural food sources, the undisputed champion of the culinary world is beef liver, coming in at 356 milligrams per 3 ounces.
It's a powerhouse.
Right behind it are egg yolks at roughly 147 milligrams per large egg. And remember, almost all of that is in the yolk, not the white. Eating an egg white omelet gives you essentially zero choline.
Good point.
Then you have soybeans, chicken breast, and salmon offering moderate amounts.
And the crucial takeaway here is that those whole food sources provide choline primarily in the form of phosphatidylcholine, which keeps that dangerous TMAO conversion low while still feeding the brain and liver.
And if we look at the safe supplement forms based on the successful trials we've covered, it breaks down by what you are trying to achieve. For brain support, memory, and focus, you want acetylcholine at 250 to 500 milligrams, or Alpha-GPC. Because of their structure, they cross the blood-brain barrier efficiently and have a very low TMAO risk.
Yep.
For liver health and addressing NAFLD, you want phosphatidylcholine up to 2,400 milligrams.
It is also crucial to mention the tolerable upper limit, which is 3,500 milligrams a day.
Right, and if you hit that upper limit, the primary side effect is incredibly distinct. A profound, fishy body odor.
Yes.
That is literally your body sweating out excess TMA because your liver can't process it fast enough. But I have to provide a relatable pushback on the diet side of things.
Go for it.
I'll be honest, I'm probably not going to eat pan-fried beef liver every day. It's just not happening.
Most people won't.
If I just eat 2 whole eggs for breakfast, does that get me halfway to the finish line?
If we connect this to the bigger picture, absolutely. 2 large eggs provide nearly 300 milligrams of highly bioavailable choline. That is more than half the adequate intake for an adult man and a significant majority for a woman. A food-first approach using eggs, along with a moderate intake of meat, fish, or soy, is the safest, most effective way to hit that daily baseline without spiking your cardiovascular risk.
You secure the foundation with breakfast.
You use whole foods to prevent that hidden metabolic crisis. Then you reserve the specific, high-quality supplements like Alpha-GPC or acetylcholine strictly for targeted interventions.
Like if you're addressing an actual issue.
Right. If you are addressing cognitive decline or providing extra support during pregnancy, you use the specialized forms under medical guidance.
That makes perfect sense. So to briefly recap the core takeaways for you today, choline is an absolute non-negotiable building block. You need it to build the structural fiber optics for your memory, you need it for fetal brain development, and your liver physically requires it to package and ship fat out of your system. But avoiding cheap synthetic forms like choline bitartrate is critical to bypass those cardiovascular TMAO risks. Form and delivery are everything.
Knowledge is most valuable when it's understood mechanistically and applied correctly.
So we want to leave you with a final provocative thought to mull over. We've talked a lot today about how egg yolks and liver are the absolute best sources of this essential nutrient.
They are.
But think about the late 20th century. For decades, those exact foods were heavily demonized and entirely stripped from Western diets due to massive public health fears over dietary cholesterol.
This raises an incredibly important question about the unintended consequences of broad dietary guidelines.
Exactly. Could that massive population-wide cultural shift away from eggs and liver have inadvertently fueled the exact choline deficiency we see today?
It's a huge possibility.
Did avoiding cholesterol for 50 years quietly cause our metabolic engines to run on fumes, acting as a hidden contributing factor to the modern surges we are seeing in age-related cognitive decline and fatty liver disease? It's a fascinating historical connection to consider the next time you're looking at a plate of eggs. Thanks for diving deep with us today.